Okay. All right, let me ask you a quick question, because this is something that happens a lot that kind of drives me a little crazy. X to the 0. What is x to the 0?
1.
You wouldn't write this, right? That wouldn't make any damn sense. Then you're effectively saying that 0 equals 1. Right? Are you guys with me? But I see this all the time. X to the 0 is not x to the 1. X to the 0 is 1. So what is log base 7 of 7?
1.
If you wrote this, what are you effectively saying? You're effectively saying that 7 equals 1. That's neat. Log base 7 of 7 is 1. You guys with me? So you don't replace part of it with 1. It is 1. So you just put a 1 wherever you see that. I like it. The other thing is, just because of the bad notation that they chose, and I will just go ahead and say, this is bad notation they chose. It's unfamiliar to us. We're not sure how something like this works, right? Some of us just see that as that, but that can't be true. These aren't like terms, are they? This is log base 3 of 5. And then I'm trying to subtract 1 from that. Are they like terms? No. So actually, I can't do anything with this. I'm done with it. That kind of thing. Okay. So it's just new notation that we got to get used to. What can I do in number 1? So yeah, the power. So I would take the power on this guy, and I would add it to the power on this guy.
You're able to solve one of the logs.
Good. And then log base 3 of 3 is 1. That whole thing is 1. And what's log base 3 of x? I don't freaking know. I love it. She's my I don't know woman. I like that.
So then you just leave
Third
it
base.
like that.
Yep, that's all you do. That's it. It's sort of like, if I had, it's sort of like ending with 1 plus cube root of x. It's sort of like that being the answer. Can you do any more with that? No, you can't. So it's fine. All right, so I had a part that I could do, and I had a part that I couldn't do. That sounds very familiar. What about number 2? We basically did that one already. I forgot that was my example. Yeah, log base 12 of 12. So you see how these are the opposite directions? This started with a product and I broke it up. This started with a sum and then I put them back together. Right? So log base 12 of 12 is 1 because 12 to the first power is 12. All right, maybe how we doing? Any questions on that? So just get used to how you can check your answer because your brain might say one thing and then you can always check it. 12 to the first is 12. Cool, that much looks good. Always check your answer, especially if you're brand new to logs. Okay, maybe. Yes?
So the whole answer would be that, or just the 1?
This is my answer, yeah.
Okay.
Yeah. Because that immediately becomes this, but then I can simplify it even further. Sort of like if I had, this is very much like, and again, there's a lot of similarity between logarithms and radicals, because they deal with sort of the same thing. And let me, real quick, on the subject of that, radicals don't know what the base is. So if I said cube root of 27, it knows the power wants to be 3. It's asking what's the base have to be with the power of 3 to make 27. You guys see what I'm saying? We don't look at it that way. You're like, why make it difficult? No, I'm trying to make it comparable. Right? So this doesn't know what the base is. And we know the base is 3, right? If I said 4th root of 16, it doesn't know what the base is. What's the base with the power of 4 to make 16? What would that be? 2, because 2 to the 4th is 16. Now, we ask the question a different way. We don't say that. We just say, what does it take 4 of to make 16? But it would be the same thing as saying, what number do I raise 4 to get 16? They mean the same thing. Logarithms know the base. Logs know the base. They just don't know the power. So that's why they're two separate functions, but they are very similar, because they're both talking about something to a power, right? Just radicals don't know what the base is, so we figure out the base is. Logs don't know what the power is, so we got to figure out what the power is. So what would the answer there be?
2.
Yeah, because it's 6 squared is 36. Maybe not. Okay, shoot. All right, so here.
Log 5 to the third power minus log 3 to the fifth.
Log 3.
Oh, yeah.
Log 3 to the third power.
Yeah, and yeah, log base 3 of 3. Now be careful, there's no power in that, what I've just written, right? And you guys just got to get used to this. There's no power in what I've written. It's log base 3 of 3. This 3 is just a normal 3. This is the weird 3. That's the one that's down there. It's a base. How are we doing so far? Is that cool? So just be careful what you say because your brain starts to latch onto that and you do weird things. And I'm dividing, so I have to do
Take away
minus log base 3 of
5.
Now, real quick, why does it make sense the 5 is the one that's in minus? Because where is the 5?
The bottom.
On the bottom. So what if I rewrote that? Now go with me. And you guys are like, that's all we freaking do, man.
It's supposed
Don't
to
even
5
ask.
minus a 6.
Watch. Just watch. You don't have to do this. Don't even write this. If I had this, couldn't I write this as log base 3 of 3 times 5 to the negative 1? Is that, do you guys see that? Is that all right?
No. Yes.
Why not?
Yes.
Yeah, 5 to the negative 1 would put the 5 on the bottom, wouldn't it? Just go with me. You don't have to ever do this, right? And what do I do when I multiply two things with logs? Log base 3 of 3 plus log base 3 of 5 to the negative 1, right? Because when I multiply things inside, I can make it the sum of the powers. But what's that negative 1 power do if I wanted to? I could bring it down. So that's why it makes sense that the bottom is going to be one that's minus, because it's on the freaking bottom. It would have a negative power that would come out. That's why we don't do it this way. We just go straight to subtraction, because that's a shortcut to this. Maybe. So this property is actually the same as this property, just with negatives, just with something on the bottom. But we just go straight to calling it subtraction. What can I do here? What is log base 3 of 3?
1.
So replace this with what it is. Looks better as 1. What is log base 3 of 5? I don't have a clue. So I'm just going to write log base 3 of 5. Because I don't know what it is. So that answer goes there, and that goes there, and this is the total answer altogether. Some of you guys are just mixing and matching, stuff is jumping around. Replace a part of something with what you know it to be. If there's something you don't know what it is, it's going to stay exactly the same, because I don't know what the hell it is. Log base 3 of 5 stays log base 3 of 5.
Log base 3 1 minus 5, or it has to be with
So that doesn't, if I had 1 minus 5x, do I have the option of calling that 1x minus 5? Are those the same? Are those the same? Come on now. Are those the same? Right? One has got a 1 and a 5x. The other one's got an x and a 5. Are those the same? No, I can't just move my variable around, because all of a sudden now I don't have 5x's anymore. I've got 1x. How did I do that? But do you see how this is the same thing as asking, can I just move this log 3 over there? It's actually even worse than that. Do you see how it's, again, you guys are brand new to this, but I'm trying to make a point that it's based on stuff that we know already that we can't do. So I gotta leave it like that. Okay.
So what are you saying? We can't write log 3 of 5 and then minus 1?
Well, that's closer to right, except the 1 is positive and the log 3 is negative, right? So you could take, if you wanted to, you could take 1 minus log 3 of 5 and write it as negative log 3 of 5 plus 1. Those are the same. Those are the same all day long.
Yeah.
Just you can't change your negatives, and you can't make log 3 suddenly go on something else. You can't have it just hop over. Now you're totally changing the whole idea of what the answer is.
Yeah, it's the same, but yeah.
Okay. That was beautiful. I should have said it like that. Sorry, I like that. All right. So here, this was when it starts off as division, I can write it as a subtraction between the logs. If it starts off as a subtraction between logs, I can rewrite that as division. So it'd be log base 5 of
75 over 3.
75 divided by 3.
Which is 25. Or you
Yeah.
see it like that.
What's 75 divided? So I get log base 5 of what's 75 divided by 3? 25. What's log base 5 of 25? 2. 2 is my answer.
Oh.
Do you see the steps there?
Yeah.
Some of you guys try to do weirdness. When you put a 25, that's just the inside. This is still there. So if I said the square root of 2 times 3 and somebody said that equals 6, what did they do wrong? Is this correct? Square root of 2 times 3, is that equal to 6? What's the square root of 2 times 3 supposed to be? Square root of 2 times square root of 3 is? Square root of 6. So see how that square root is a function? They just left the function off. If you said log base 5 of 75 divided by 3 equals 25, you did the same mistake as this person. The exact same mistake. You left the function off. Right? What's being done to 2 times 3? It's being square rooted. So it better still be there. What's being done to 75 divided by 3? It's being log base 5th. Right? So that log base 5 better still be there. Again, I think most of the trouble people have with logs is the unfortunate choice of symbol. It's a little word, and it's like it gets us all like, what the hell? Can I subtract a log? Just take a log off the stack of logs? Can I make a freaking cabin? There's all kinds of stupid jokes about that. Right? You can't divide by log. Doesn't make any sense. Can't make it. Yeah. What I mean by what I just said is I get people that do stuff like log base 5 of x equals 2. And this is what we're not going to get to, is solving equations like this. But this equation will be really easy to solve. What's the correct way to solve this equation? You guys can do this, believe it or not. What's another way to write this?
5 squared equals x.
Yeah, 5 squared equals x. The answer should be 25. But I'll get people that are log base 5 of x equals 2, and they divide by log base 5. And they say x equals 2 over log base 5. Yay! And some of you guys are like, well, what's the matter with that? It's the same thing as saying solve square root of x equals 7 and dividing by the square root sign. Yeah! Yeah! There you go. X is 7 over the square root sign. Because the square root sign is the same, does the same job sort of thing as a log-based something. They're both function notation. They're both symbols. It's just that they took the word and it just throws us off. Okay. What about down here?
We list numbers, right?
Yeah.
I'm sorry. 3. Now I could use subtraction, or I could just figure out what's the understood base.
10,
What do I raise 10 to make it 1/10?
-1.
-1. So the answer should be -1. Let's try to do it using this property. How would I rewrite this?
Log base 10, or
Yeah,
log
sure.
10.
Log 1 minus log 10. Got it. I want to write the base. The base is understood to be 10. What's log base 10 of 1?
0,
0. What's log base 10 of 10?
1.
1. I like it. Hear that? Somebody's texting. Yeah, I'm in math class. Yeah, it's weird shit. Yeah. All right. Same weird shit. Same shit. Same, but it's weird. What about this guy here? Using this property. What's the only thing I can do with this?
Move it over.
Move what over?
The 2,
The 2 can come out.
2, 1, 3.
So those are the same thing. Log 3 of a squared is twice what log 3a is.
Kind of confused with why are we bringing the 2 out? What's the?
Because we're allowed to.
Why do we want to?
Watch. Why do we want to? I'll show you. So,
I just don't really understand why we're doing that.
you ready? This is, unfortunately, we're not going to make it this far. But if I had, for example, if I had 3 to the x equals 11, and I want to know exactly what the answer is, because we know what's the answer close to. Just a little bit above what? Careful, it's a little bit above 2, because 3 squared is 9. But I want to know exactly what the answer is, so I have to solve this. Thank God we have a property that logarithms take anything in the power and it takes it down. Why is that good? Because where's my variable? Where's my variable? In the power. That so sucks. Right? It sucks if it's in the bottom. That sucks. Right? So 1 over x, 2 over x plus 1 minus 3 over x squared plus x, blah, blah. And we did this whole thing about how to get the x's up. Right? It's all about getting them unstuck from wherever they are. So this would just use multiplication because they're stuck because of division. This, holy shit, what's the opposite of an exponential? Is a logarithm, thank God. So if I did, now watch, if I did log of both sides, what would happen? This would
Move.
come down. Thank God it would come down. Now how do you solve this? This is x times this equals this. How do you get x by itself? Divide by log 3. So then, because log 3 is just a number, right? It's base what? What's the base understood to be? 10. So log 3 divided by log 3 is 1. X equals whatever the hell this is. And then I can put that in the calculator somewhere and estimate it. That is the biggest and most important reason why we want that property to exist, is because I want to be able to solve equations where the x is stuck up here. So I need a function that can free it. And the logarithm function is the only one that can free that power and make it come down. Now, if your question more, so that was part of your question, was why do we even want that?
Yeah.
Right? Does that sort of make sense? I mean, the biggest, most important thing algebra does immediately for most people is it solves equations. Because what happens when we go and make observations, we make an equation from what we see. So I want to be able to solve those damn equations so I can tell people in Florida if the hurricane's going to hit them or not, right? And that would be an ugly-ass equation. I never want to become a, oh my God, these poor people. Weather equations suck so bad. That's why we need to be able to do that. Now, part of your question, I don't know what part of your question was, why are we able to do that? Is that part of your question also?
Yeah.
Okay. So that was one part of your question. That's the immediate answer I can give you. There's more than this, but this is the most important immediate thing, is to be able to solve equations. That's right. When my variable is stuck up here.
I didn't really understand how you're just like, when you put the log in front of the 3 and 11 and just bring out the x, you know.
All right. So watch. Just a second. If I have this, what would I do? Square root. Why? Because the x is sort of stuck inside of a square. So how you kill that square? You square root, but you apply a square root to both sides. Is everybody with me?
Yeah.
All right. So if I have 3 to the x equals 11, what function am I going to apply to both sides? I'm going to apply the log function. So what did I do? I took the square root of this side equals the square root of that side. What the hell's happening? They're making a new doorway here. So now watch. Oh yeah, Kool-Aid. Oh yeah. Oh no, Joe's down. Oh, so, what am I going to apply to both sides of this? I'm going to apply the log. I'm going to take the log of this. If I take the log of that side, I better take the log of that side. And again, I really think most people's trouble with logs are because it's a little word. If it was just a symbol like a square root, you wouldn't have that much trouble. You know, oh, I'm doing that to that side. Well, here I am doing the log of both sides. And since I did that, what can I do with that x? I can bring it down. It's a property of logarithms. All right. I mean, that's all there is to it. Now, the other question is more important. Why can you do it? So I think on that one it was this, right? Yes. True? Can I say this is log base 3 of a times a? Isn't that the same thing? And then I can use the first property. What's the first property say? If I have something times something in a log, I can rewrite that as log base 3 of a plus become a g and a 3. Log base 3 of a, right? Well, how many log base 3 of a's are there?
2.
There. So screw this middle part, just take the 2 down. Because there's going to be that many of these. So if it was a 7th power, I would have 7 a's. I would have 7 of these. So I have 7 of these. So the shortcut is just take the power down, because that's how many you would end up within a row. Sweet. All right, good. That's the one I really want you to understand. The other one, if you don't buy why it's important, math teachers kind of are like, if there's not enough time, they're like, oh, screw, I can live with that. That's fine. Just understand it's freaking important as hell, but if you don't understand why, okay, at least understand why it works. I like that. A little a compromise. All right. So again, this was going to just be 2 log 3a. What about this guy? Why is this guy easy? Because a is written with a power on it, and logs are all about powers. That's what they represent. So what's wrong with the way this is written currently?
Right in the power.
It's not written as a power. It's written in that form where you actually never even need it, but oh well, we got it. So I can rewrite this in a better form. Log base 5 of x to the
1/5.
1/2, right? It's the square root. And then what can happen there?
Well, is it square root because of the half? I mean, is it half because of the square root?
Exactly. If it was a cube root, it'd be 1/3, right? Because it cuts it in thirds. Square roots cut thing in.
Because the 2
half.
is just automatically read.
2 is known to be there, just like log has a 10 on it. Yeah, that 5 is part of the log. It's log base 5. And the root is a square root. So what can happen with this 1/2?
Goes to the front.
So it can become this if I wanted to.
1/2 log base 5.
And again, if I had more terms, and some of them were log base 5 of x, now this is like terms with those now. I could put them together. I'm like, sure, Jeff, whatever. So if I had, for example, real quick, this is a lot like the radical equations where we had to simplify them to get like terms. If I had log base 3 of, let me think of something here. Log base, log base 3 of 25 minus log base 3 of 5. Watch this. This is kind of nifty. This is a whole different way to do this. 25 is 5 squared, right? Is that cool? And what can happen with the 2? It can come out front. So I got 2 of these minus 1 of these is 1 of those. Cool? What's the more direct way to do this? I mean, this is kind of a long, drawn-out way to do this, but what's another way to do this? 25, log base 3 29 minus log base 3 5. So what do I do with these? Divide them. 25 divided by 5 is? 5. Bam. Same answer. Right? Okay, maybe. Alright. So, where'd it go? Did I do that one already? There it is. Yay. So what about this last guy? Now this one is funny.
Log W E of R over 2.
Well, r to the 1/2 if you wanted to. Why do you not care? What happens with whatever the power is? It just comes out. So on this one, why did I have to write it as a 1/2 power? Because I couldn't see the power. This one, what is the power? Rad R. So if you wrote it as r to the 1/2, who cares? Whatever the hell it is, it comes out. So I don't even have to, because I can see the power. I don't have to rewrite it. I can just see the power and I can take it out. Fight the power.
Go from R over to log W E.
Careful now. If you rewrote it, r to the 1/2, not half of r, but r to the 1/2. So then this would come out, r to the 1/2. So these are the same, aren't they? R to the 1/2 is square root of r. So either way you wrote it, it's the same thing.
So why are you writing the R in there? Why didn't you write the X over there?
Oh. What's the base in this problem? What's the base?
5, right?
Well, 5 is the base of the log. What's the base inside? X. So the power on that base is going to come out. So of course the X stayed inside. What's the base here inside? E. E is going to stay inside. Its power is going to come out.
Okay.
See, the square root of X is the argument. The square root of R here is the power.
Okay.
So what's the property of log? Whatever the power is can come out. So this one was harder because I had to write it just to be able to see the power. This one, I can see the power. Power is square root of R. So what happens with the power? It comes out. Yes?
Like on question number 2, are we expected to see actual numbers except variables in outcome the test?
That would be an exact question I could ask on the test. I could say, rewrite this in a different form.
Oh, but what if it wasn't a variable, but it was an actual number?
It would work the same way.
Okay.
Yeah. If you put a 3 in there, it'd just be a 3 there, it'd be a 3 there.
Professor,
Yes?
can you go over number 3 again?
This one?
No, that.
This one.
Yeah.
So this was just log 1
Minus 10.
minus log 10. What's log 1? What's any log of 1?
10. 1.
0. What do you raise anything to make it 1? You raise anything to the 0 power to make it 1, right? So what's log 1? 0. What do you raise 10 to get 10? 1. That's why it's negative 1. That's one reason why it's negative 1. Alright, yes ma'am.
Are the last number 3 going to accept both answers?
Oh, either one of these? Hell yeah. They're the same thing. So if you wrote a square root as a 1/2 power, I can't say a damn thing because they're the same thing. And in fact, you know me, I wish we would have never invented radical notation. We don't need it because we already have fractional powers mean the same thing. Anyway, somebody's like, stop saying your own feelings, Jeff. Oh, sorry. Let's do this. Let's take a break. I get a feeling we need a break desperately.
No, that's pretty easy.
Let's take a break. Come back at
You know why it's pretty easy?
5 past.
It's easier for you.
And then I'll give you guys the answer key. We'll review